So hi everybody, today we're going to do the limiting reagent laboratory, and we're going to be using the chemical reaction of potassium mixed with lead to nitrate to form potassium nitrate and lead to iodide, which is a solid precipitate. And we're going to be collecting that precipitate to measure our product so that we can be able to see an actual versus a theoretical and be able to calculate then, of course, the amount of percent yield both in the PBI2 and in the KNO3. So right now I have already measured out 50 milliliters of water, as the first step says, and I'm going to pour that into my beaker. There is my 50 milliliters of water, and I am going to go ahead and add to that 0.891 grams of potassium iodide, and I'm going to stir that up to make a solution. So right now I am adding all of my potassium iodide, and I've got to scrape it off here, get it all into my beaker. So my watch glass is my watch glass is empty. That's a weighing watch glass, and I'm going to go ahead and stir this up all the way, and you can see that in fact I have made a solution. Remember, solutions can be identified by dissolving a solid into some water, and I make a transparent solution with that solid all dissolved. So that is my Ki solution. And I am also going to go ahead and make a lead to nitrate solution. And my lead to nitrate solution is going to be made with, as you can see, 1.059 grams of lead to nitrate. And yes, everybody, you should be recording these values right here on your data table. So you should have this data table open, this paper open on your desktop, and you should be recording these two values. Here is the 0.891, and here is 1.059 grams. Okay, and I am going to go ahead and get all of that into, and I forgot to put the water in. I'm going to go ahead and add the water right now. And that is going to be also, let's see here, potassium iodide is distilled water, approximately 1 gram of lead to nitrate. Alright, so what this says to do, and I got ahead of myself, is to add that potassium nitrate, which you might be able to see is a white powder, to my lead to nitrate. And so I am going to go ahead and dump all of it in there, and you might have already realized that in fact, and I got to make sure all of it gets in there, you might have already realized that in fact we have made a bright yellow, no longer transparent product. Now, the fact that it is no longer transparent should be telling you that in fact what we have made is a solid. If we were to look at it sideways, and let me see if I can show it to you sideways, you can already see that the product is starting to settle to the bottom of the beaker. Okay, so I have also obtained a piece of filter paper, which you should make note on the side of your laboratory that the filter paper mass is 0.511 grams. After we get done using our filter paper and collecting all of the solid, we will want to subtract the mass of the filter paper from the total mass of the solid that remains in the filter paper after we dry it. So to prepare my filter paper, I'm going to first bend it in half, and then I'm going to fold it again into quarters. And so this makes a lovely cone shape, and I am going to put that cone shape into my funnel. Now to make it be a filter, I'm going to put 3 sides on one side and 1 side on the other. And I am going to go ahead and get this wet, because otherwise it won't stay in there. So what I've done so far then is I have gotten this wet. So you can see it is now wet. And so what I'm going to do is I'm going to filter this solution into another beaker. So what I'm trying to do is a physical filtration process to remove the solid precipitate from the liquid solution. And I am going to go ahead and stir that back up again because I want as much of the solid to be into the filter paper as possible. So I'm going to start the filtration process. And as you can see, that is what it looks like right there. And it immediately starts filtering, and I'm getting a clear liquid as we go here. I'm going to pause my video and go ahead and get it all filtered for you as we go. Okay, we are getting close to the end of our filtering. There's still a little bit of liquid in there. You might also notice that I'm getting a clear solution that is our filtrate that is coming through, and I'm collecting the yellow particles of the solid in my filter paper. What you might also notice is that my stir rod has a very small amount of yellow particles on it, but you also might notice that my original beaker still has some yellow particles in it, and I really want to get those out. So I'm going to go ahead and pour a little bit more water in here and mix that with the yellow particles that are still stuck inside the beaker. And I want to go ahead and pour those yellow particles into my filter paper to get those yellow particles also included as a part of our measurement. Now, you will notice that I still have a little bit left over, and so in addition to what's left in here, what's stuck on the stir rod, and as you can see, what got spilled just a tiny bit on my paper, it looks like I didn't quite get all of the yellow solid precipitate into the solution. All right, I'm going to pause it once again while it finishes up with its filtering process, but as you can see, we are getting a clear liquid and a yellow solid. Okay, we have reached the end of our filtering, and as you can see, we have a filter paper that is full of a yellow solid. It is still wet though, so I am going to finish up this by drying the filter paper with paper towel as much as possible, but then placing the filter paper onto a watch glass and putting the watch glass into my oven to let it dry so that we remove all of the remaining wetness on the filter paper. So when we get done, we will have a final mass of the filter paper and the solid precipitate that we get afterwards. While we are waiting, I'm going to get you to change your point of reference to the second page. And on the second page, we are referring to part 2, determining the amount of excess reagent left over. We have actually saved the amount of excess reagent. We've actually figured out how much product we have, the other product here. And as you can see, that is just a clear liquid. And so what we want to determine is how to figure out what is actually in this solution. It is possible that we still have remaining in this solution some original excess reagent, but we also have remaining in this solution the other reagent. So far we have taken out PBI2, the solid, and removed it completely. So as you can see, that's why we have a clear liquid left. So if everything is 100% perfect, then we have KNO3 aqueous left in this beaker. But if it is not, then we have some mixture of the excess reactant and KNO3 both dissolved, making an aqueous solution of both of them. And what we have to figure out is how much excess reactant is left over. And we're going to do that by trying to obtain the crystals of what was dissolved in here. Now, you and I both know that there are no crystals that you can see. There is nothing there. It is empty. It appears to just be water. And I can tell you for sure that this is not water. This is a solution of water and KNO3, as well as one of these two remaining as the excess reactant. So to be able to get this separated, we need to use a different physical means of separation that is not filtration, because obviously there is nothing to filter. Instead, we are going to use evaporation. And so we are going to evaporate this solution to dryness using something called an evaporating dish and a hot plate. Okay, here is our evaporating dish, and of course it is sitting on the hot plate, and I have measured the mass of the empty evaporating dish as 48.997 grams. All right, so since we know the mass of the empty evaporating dish, then when we pour our solution into our evaporating dish and let it have the time to boil, and evaporate completely, then what we'll be left with is nothing but the residual amount of solid that was originally dissolved in here. So we are going to let this sit and boil and evaporate over time. Yes, I'm not going to make you watch it on screen, but we are going to evaporate this to see if we can figure out what mass of solute is actually in this solution. So here we go. Okay, while we are still waiting for the solute or the solution to evaporate, it's going really slowly over here. We did get a solid of the precipitate to actually dry out. So we're going to go ahead and take that mass so that we can record that, and you guys can record that in your data table. Okay, so the mass of the filter paper and PBI2 can be reported as 1.682 grams. Now, that is the two of those together. To be able to report the mass of just the PBI2 produced, we are going to have to subtract. So mass of the PBI2 is going to be 1.682 grams, subtracting the mass of the dry filter paper, which you might remember was 0.511 grams. And I'm going to let you record that value into your data table. So when we are talking about your data table, we literally are talking about in the data table right here after you remember to subtract the 0.511. Now, this value right here is going to need to be calculated by you, starting with the mass of the Ki as one of your reactants, and then starting again with the mass of the PbNO3 to determine what the theoretical mass of the PBI2 could be that was produced. Once you know that, and you know this, you can calculate the percent yield of PBI2, and then we're still going to have to talk about the percent yield of KNO3. So I'm going to pause that until after we get a chance to finish this evaporation. Okay, as we are getting down here to the end of our evaporation, you might notice something strange and odd, and that is from that clear solution that we started evaporating, we are actually getting a residue that is both lighter yellow and darker yellow. And you can see that, in fact, even though we filtered very carefully and we thought we got all of the solid precipitate out, it does appear that we missed some of the solid precipitate. So what we are getting here then is actually going to be a mixture of all kinds of things, including what we expected to get was KNO3, which should have been a white powder. And you can see some lighter yellow, which might be intermingled with some KNO3. But you're also seeing some darker yellow, which is probably the lead to nitrate. And we are probably also seeing some of the original Ki mixed in here as well. So as you can see, we did have things that were dissolved in our solution, and as the solution completely evaporates, we're beginning to see some evidence of what is actually still, what was dissolved, in other words. So I'm going to go ahead and let this finish evaporating, and then we will take this mass. Go ahead and mask the mass of this evaporating dish and the dry solute. So as you can see, we still have a bunch of yellow still remaining here. And this, as we've already talked about, is probably a mixture of things, including the KNO3, including the rest of the precipitate that we didn't quite get filtered out, and probably also including some excess reactant. So we are going to need to be able to determine our percent yield of both the PBI2 and of the KNO3. To finish this laboratory, we are going to need to first calculate a theoretical mass of PBI2 produced. Remember, we have a limiting reactant situation. In other words, whichever one of these two reactants in a mass-to-mass problem makes less PBI2, that one is our limiting reactant. So once we've determined which theoretical mass is less, that's going to be the actual theoretical mass we're expecting to see. Now, what about the yield, the percent yield? Well, the percent yield will be the mass of the limiting reactant. The actual mass, this actual mass of PBI2 produced, divided by the theoretical mass of the PBI2 times 100, and that will give us the percent yield. How about that percent yield of that KNO3? All right, so KNO3, we are going to have to do one more calculation of mass to mass. So this one will be a mass to mass, and we want to know how much KNO3 would have been produced. So if we know how much KNO3 should have been produced from the limiting reactant, not the excess reactant, from the limiting reactant, then we can say, okay, then we know a theoretical yield. We know an actual yield because we have this mass here, which is the mass of, let me find it, this mass of the evaporating dish and dry solute minus the evaporating dish. So we know the actual, and we can find the percent yield of the KNO3. All right. So, and I imagine there's going to be a lot of questions here, so we can talk about it some more. But the final things that you need to do is identify both the limiting and excess reactants, and this should be in a paragraph format. Determine the percent yield of each reagent. Explain why your yield was not exactly 100%. I will give you some hints. Look at my spills. I will give you some hints. Look at the evidence that some of the actual precipitate was left over in the solution. Okay, those are my examples of why our percent yield was not actually 100%. And then propose some improvements to the laboratory procedure that would give you better results if you were to do this experiment again. And that's what you need to write in paragraph form at the bottom of your laboratory. So after you have completed your calculations, then you will write about it. And this lab is going to be due, I'll probably go ahead and make this lab due on Tuesday and Wednesday of next week, giving you plenty of time to get this laboratory done. So there is that.